So we're going to talk about slope. We're going to continue with our sequence formula and kind of see how that connects to slopes of lines, whether they're increasing or decreasing. So we're first going to look at this graph we have here, and we're given the equation a sub n equals 20 times n minus 1 minus 30. So the first question says, what is the common difference of this equation? So remember, the common difference comes before our parentheses. So the common difference here is 20. Now we're going to look at the graph, and it says going from one point to the next on the graph, what is the vertical change? So I'm going to look at this point and this point. So this point is at 35, and this point is at 45, 30, and 50. So the graph is going up by 20s for the vertical change. And then the next one says to look at the points horizontally. So if I look here, this point is at 4 on the x-axis, and this one is at 5. So the horizontal change is 1. So rate of change is the vertical change divided by the horizontal change, and so that is what the slope is. So if we were using the graph, the vertical change was 20 over the horizontal change, which is 1. So that's actually going to just simplify down to 20. So if we notice, then our part from A, where our common difference was 20, is the exact same as our slope. So the connection for E you can write is the common difference of an arithmetic sequence is the same as the slope of the line. The next problem says the table shows the distance a van marches over times is the rate of change in distance with respect to time. So what is the rate of change and what does it represent? So when we're looking at the table, we have to check our rate of change. So our time is going up by 1 minute, and our distance, if we subtract 520 minus 260, our distance is going up by 260 each time. So again, that's the vertical change over the horizontal change. So we're going to take 260 over 1, which is just 260. But then it says, what does it mean in context of the problem? So that means 260 feet per minute. Next, we're going to find the slope of these two lines. Since we're given a graph with 2 points, we can just count the rise over run. And then remember, we have to look at the line left to right to say if it's increasing or decreasing. If it's increasing, it's positive. If it's decreasing, it's negative. So this line here, since it's going up left to right, it's increasing. And the slope, remember, m is our variable for slope. We're going to go rise over run. So this one, we go up 2 and over 3. So our slope is 2 over 3. And it's positive because, again, it's going up left to right. Now, if we come over to the next graph, we're going to do the similar thing. We have the point -3, 2, and the point 2, -2. So if I'm looking at this graph from left to right, it is going down. So this graph is decreasing. So that means that my slope is going to be negative, and then I'm still just going to count rise over run. So I go up 4 and over 5, so the slope is -4 over 5. The next kind of way we're going to find slope is using the slope formula, which you will have to memorize. So our slope formula, and you can just make that the letter m instead of the word slope, is y2 minus y1 over x2 minus x1. So to use that formula, if you have 2 points, we're going to label our points x1 and y1 and x2 and y2. Doesn't matter which one is x1 and y1 and which one is x2 and y2 as long as your 1's are together and your 2's are together. So now if we plug it into the formula, we have m equals y2 is -2 minus y1 is 0 over 3 minus x1 is a -1. So on the top, that's going to simplify to a -2. Minus a negative is the same thing as plus. So 3 plus 1 is 4. And then we have to just reduce that and make that in simplest form. So if I divide the top and bottom by 2, I get -1 over 2 as the slope of the line that goes through those 2 points. The next two problems we're going to look at are horizontal and vertical lines. So we're going to look at what happens when we take these 2 points and put them in the slope formula, and then just kind of talk about a general thing for horizontal and vertical lines. So this would be my x1, y1, this is my x2 and my y2. So in my equation, I would have 2 minus 2 over 2 minus a negative 3. That's going to become 0 over 5. And 0 over 5 equals 0. So any horizontal line has a slope of 0. Now we're going to do the same thing for the vertical line. I'm going to take off those 2 points there. So we've got a negative 2, 1, and a negative 2, negative 2. So I've got x1 and y1, x2 and y2. If I plug into the formula, I've got negative 2 minus 1 over negative 2 minus a negative 2. And that's going to become a negative 3 over 0. Now we cannot divide by 0, so we call this undefined. So any vertical line always has a slope of undefined. Now, the last thing I want to talk about is not on your paper, but I just want to go over because it's going to come up on the worksheet. So we have the y-intercept. So what the y-intercept is where the line's going to cross the y-axis. So remember, our y-axis is going to be this vertical line here. So what I'm looking for is the point where it crosses that line. So I'm going to look at the blue line here. So the blue line, I'm kind of looking where it's intersecting with the green. So it's intersecting there at 6. Now, since we're just going straight up on the y-axis, our x is 0 and our y is 6. So the y-intercept is 0, 6 for the blue line. Same concept for the red line. I'm looking for where the red line is meeting the green line, and that is at negative 4. So again, we want to write that as an ordered pair. So our y-intercept is 0 because we don't go left or right any, and then we go down 4. So 0, negative 4 would be the y-intercept.